and we are looking at properties of limit of a function. If you have not subscribed to this channel, kindly subscribe and also share with your friends. Now let's look at properties of a limit of a function. In my previous tutorial, we had looked at definition of limit point of a function. So if you have not looked at this, kindly press up there in my channel and you'll be able to see that. And if you have question on or any comment, kindly leave a comment in the comment bar so that we are able to check out and also share with our fellow colleagues. Okay, so first property of limit is that the limit, if it exists, then it's uniqueness. And if you have a given limit 1, another limit of function limit 2, then the functions, if you sum the functions, is same as summing their limits. Okay, that is uniqueness, and you can sum the functions and get the limits overall, and you get like getting the summation of their limits individually. Then you can even multiply the functions and it will be same as multiplying the limits individually. But again, if you divide the functions, is same as also the limits of the functions is also like events the individual limits. Of course, when the denominators are not 0, even L2 is not equal to 0, because if that happens, this becomes undefined. Okay, so you have seen that we have 4 main properties of a limit. That first is unique, secondly you can sum, you can multiply, and you can divide. Okay, now we have just to elaborate something on this. For example, if you could have limit of x as this tends to 0 for x squared minus 4 over x minus 2, you can see here, you can substitute there. So you do the window limit for that and the limit for this. They'll be able to get applying 4, and so on and so on. So if you have a question on this, you can leave a comment and I'll be able to check on it. Okay, one-sided, we have another property. Let's look at a one-sided limit. So if you let S to be, contains the real set, and let fx to be in real set be a function, if it happens like that, if for every x in S, fx tends to the limit L as x tends to C, and in this case x is greater than C, okay, always we say that x tends to C from the right. X tends to C from the right, and we write x to be positive. So it's from the right, because in this case our x is greater than C. That should imply that C is like C is moving to x. Therefore, we are saying that this is a positive, is a right. You see that x tends to C from the right, and we write it like x tends to C plus. Therefore, we write that limit as x limit x tends to C plus, that's the right side, fx equal to to the limit. Similarly, if you have x in S and f(x) tends to L, you find that x tends to C, and it happens that x is less than C. We always say that x tends to C from the left, because x now is less than C. So x somehow is approaching C, now it's from the left side, and then we note it like this. We notice from like that. So this is one-sided limit. Okay, generally, if you find that the right limit and the left since give the same limit, we say then those are one-sided limit of function at a given point x in C. If you can find both x as from right and left, so we call those ones are right. Because that one-sided limit of the function at a given point. That given point. So let's look at a theorem. We let S to be condensed in the real set and S tends to R. Then we say that the limit of x x to 1c tend to C of f(x) is L if and only if you find that both the right and the left limits are equal. If it happens that they are equal, then we say that the limit of that function at the point C is that particular value of L. Okay. So if you have a question on either of these, leave a comment and also subscribe and share with your friends.